Hi everybody, welcome to 2014. Here's our first video notes of the year, and it's about the mole. Woo! So here are the 4 things you should be able to do after we're done. Hey, you want to know where to find in the book? Check out chapter 8. So what we're going to talk about with chemistry is the things that make it up, and those things are particles. And if the particle has a charge, it's called an ion. If the particle comes from an ionic compound, it's called a formula unit. If the particle comes from a covalent or molecular compound, it's called a molecule. What represents elements? Atoms mostly, unless they're diatomic elements, then what represents them, the particles that make them up, are called molecules. So make sure you know that these are the thingies of chemistry, or the particles that represent those types of substances. So all of these thingies are really small. I mean really small, really, really small. So say you had a cell. Oh, I have a cell. There might be 7 times 10 to the 15th atoms in that one cell. Okay. Now, if you had a grain of salt, woohoo, there might be this many 6.6 times 10 to the 20th formula units in one of these tiny, tiny grams of salt. Okay, it's unimaginable. It's hard to imagine how much that really is. So because these things are so small, it's going to be hard to count them. So we're going to group them together. For instance, if I live in Indiana, which I do, I'm going to buy a ream of paper, because who wants just one sheet when you could get 500? I'm going to buy a gross of bottle rockets. Oh yeah, 144 bottle rockets coming my way. And it's perfectly legal to buy bottle rockets in Indiana. And a dozen donuts, because who wants just one when you can get 12? So why do we group things by large numbers? Because it's easier to count them that way. And in chemistry, we group things by large numbers, and that is called a mole. How many things are in a mole? Well, this number, 6.02 times 10 to the 23rd, also known as Avogadro's number, represents how many things are in a mole. Why is that number so huge? Because the particles or thingies that make up chemistry are really small. And a mole is important because it helps us count really small things. Because if you had to count out this many things, you wouldn't finish it in your lifetime, or probably 10 lifetimes. So a mole is a unit. Oh look, I have a song. Was a animal that burrows in the ground, got on your chin, but you gotta shave around. Another kind of mole of interest to me. I was singing. It's a unit of measure. So anyway, that's just a little bit of the mole song. And here's a mole, a picture of a mole. And yes, I know this looks like a mole, but really it's a potato. I'm not kidding. So we use a mole in chemistry because it helps us measure or count how many things we have. So if I asked you how many of what are in 1 mole of something, if I said how many are in 1 mole of water, you'd say, well, those are molecules. So how many molecules in a mole of water? 6.02 times 10 to the 23rd. Helium. What represents helium? Helium is represented by atoms. And so how many atoms are in a mole of helium? 6.02 times 10 to the 23rd. It's a lot of atoms. Calcium fluoride, CaF2. That is the chemical formula of calcium fluoride. And since it's ionic, it's called a formula unit. Formula unit. All right. And so how many formula units are in 1 mole of calcium fluoride? If you said 6.02 times 10 to the 23rd formula units in 1 mole of calcium fluoride, you'd be right. Now, how many calcium ions are in a mole of calcium fluoride? Well, there's 6.02 times 10 to the 23rd formula units of calcium fluoride in 1 mole. 1 mole of calcium fluoride. But just like that people have 2 legs per person, there's 1 calcium ion for every 1 mole of calcium fluoride. So there would also be 6.02 times 10 to the 23rd calcium ions. But if I asked you how many fluoride ions are in 1 mole of calcium fluoride. Since there's 2 fluoride ions for every 1 formula unit of calcium fluoride, it'd be 1 mole of calcium fluoride actually has 2 moles of fluoride ions because there's 2 per mole. So that's going to be Avogadro's number times 2 for calcium fluoride, or sorry, for fluoride ions. Now, how many times would we like to see methane bubbles on fire? Well, for sure, 1 mole of methane bubbles on fire would be the number of times we want to see it, 6.02 times 10 to the 23rd times, for sure. Okay, so gases are a little bit different because they take up as much space as you give them. But if we say, okay, you can only have 1 atmosphere pressure and 0 degrees Celsius, any gas would take up 22.4 liters of space if there was 1 mole of gas at STP. What do we mean by STP? At certain conditions, standard temperature and pressure, 1 mole of a gas takes up 22.4 liters of space. Any gas, okay? The particles are so small that the amount of space, this 22.4 liters, is going to be the same because the gas is all spread out. So no matter if you have big gas particles or little gas particles, it's 1 mole of a gas. There's Avogadro's number of gas particles, and they take up 22.4 liters of space only if it's at STP. So memorize this definition. STP means standard, S, temperature, and pressure, TP. And the conditions are 1 atm and 0 degrees Celsius. Okay, so mass is measured in grams. So you got to go to the periodic table when you want to get grams. So if I wanted to know the mass of 1 mole of a gas, then I would need to go to the periodic table. So here's nitrogen and oxygen. Nitrogen has a mass of 14.0. We'll round it to 2 decimal places. And oxygen is a mass of, we'll go 16.00. So the mass of 1 mole is 30.01 grams. So 1 mole of NO2 would have a mass of 30.01 grams of NO2. How do we do it for carbon dioxide? Well, if you want mass, you got to go get grams from the periodic table. So 1 mole of carbon dioxide would be 12.01 because we have 1 carbon. And then oxygen, there's 2 of them, so 16.00 times 2. So we'd get 44.01 grams. So how would we write that? 1 mole of carbon dioxide has a mass of 44.01 grams. So we got to go get the mass from the periodic table. Aluminum oxalate, wowzers. So we would say aluminum has a mass of 98 grams. And then there's 2 of those. Carbon, be careful, there's 2 in oxalate, but there's 3 oxalates. So we have 12.01 times 6 equals 12.01 times 6 equals, and then oxygen, there's 16.00, and there's actually 12 oxygens in this compound. So then you multiply and add it all up. So 26.98 times 2 plus 12.01 times 6 plus 16, I gotta put a parentheses, 16 times 12 closed equals, I get 318.02 grams. So 1 mole of aluminum oxalates would actually have a mass of 318.02 grams of aluminum oxalate. All right, so 1 mole has Avogadro's number of particles. 1 mole has 22.4 liters of a gas at STP, but grams are different because you got to go get the grams of each substance from the periodic table. Okay, and then so please remember this: 1 mole, if we counted the things in a mole, you'd get 6.02 times 10 to the 23rd. Now those could be atoms, they could be molecules, or they could be formula units. Formula units, because those are the kinds of particles that represent the thingies we talk about in chemistry. 1 mole also equals 22.4 liters if you're talking about a gas and it's at standard temperature and pressure. And 1 mole equals the mass in grams from the periodic table. So that's the only one you can't memorize a number for, but you can go get grams from the periodic table. So memorize this right now. Got it? Oh, look, there it is right there at the top of the screen. So now, because these are all equalities, we can use them to convert. So this question asks us to take 12.5 grams of carbon dioxide and change it into liters of carbon dioxide. But you got to go through moles. Go through moles. So I want to get rid of grams and change it to moles because I know that I can use that conversion factor. And then in the second step, I want to get rid of moles and change it into liters because I know I can use that conversion factor. So we practiced converting in the fudge lab, and now we got to use it for moles. The number 1 goes with moles because look at all of these are 1 mole equals. So what does 1 mole equal? It equals 22.4 liters of carbon dioxide. What does 1 mole equal? Well, this is grams, so we got to go to the periodic table. And we did this earlier on the slide and on another slide, so it's 44.01. So how do you do the math? It's time for your calculators. It's time for your calculators. 12.5 divided by 44.01 times 22.4 equals 6.36 liters of carbon dioxide. It has the same value as 12.5 grams of carbon dioxide. So that's just how much space that mass of gas would take up. Okay, in this one we have 19.9 liters of oxygen. Okay, when we talk about oxygen, it's almost always diatomic unless it's part of a compound. All right, so we got to go through moles because liters is in this conversion factor and grams is in this conversion factor. So we have to use 2 of them. Liters of oxygen have to cancel and change to moles. So we're using that bottom one as a conversion factor. And then we're using the middle one here. So then we get moles have to cancel out, and we have to change it to grams of oxygen. So what number goes with moles? Moles are number 1. What number goes with liters? 22.4 liters. We're assuming it's a gas at STP. And then grams, we got to go get grams from the periodic table. Notice that 2 there, so this would be 32.00 grams. All right, calculator time. Look at these units. Goodbye. See you later. Bye-bye. So we say 19.9 divided by 22.4 times 32 gives us 28.4 grams of oxygen. So if you had 19.9 liters of oxygen if gas at STP, it would have this mass. That's what's happening here. Okay, now we need to convert formula units of magnesium acetate C2H3O2, 2 of them. Wow, who picked that chemical formula? I did. All right, and we want to change it to grams. Okay. So make sure that you start with your given 9.55 times 10 to the 21st formula units. I'm going to abbreviate it nicely of magnesium acetate C2H3O2. Okay, and formula units are in this conversion factor, and grams are in this one, so I got to use 2 steps. Boomch, boomch. So I put formula units on the bottom, and it's magnesium acetate. What is it? Magnesium acetate. Is it anything else? Not this time. So you got to put that in there. And this is moles of magnesium acetate, C2H3O2. Wow. And then moles have to cancel out because we had to go through moles. Magnesium acetate. And we got to change it to grams of magnesium acetate. You think I would have calculated that out already. But anyway, the number 1 goes with moles because in all these conversion factors, it's 1 mole. Formula units is Avogadro's number. That's how many things. Formula units are things. There's Avogadro's number of things. Okay, moles gets 1. And then we periodic table. Magnesium is 24.31. There's only 1 of them. So then we have to add, how many carbons? 4 carbons. 4 times 12.01. And then we have to add to that 6 hydrogens, 1.01 times 6. We have to add to that 4 oxygen, so 16 times 4, close parentheses, equals, I get 142.41. Okay, periodic table, go get from the periodic table. Then calculator-wise, please use the E button on your calculator. 9.55, second E, and then we got 21. Divided by 6.02, second E, 23, and then times 142.41. Enter. I get 2.26 times 10, no, 2.26, there's no times 10 on that, grams of magnesium acetate. So we've used a conversion factor with Avogadro's number, with mass, with liters, and with mass. And now let's change liters of chlorine gas, remember chlorine is diatomic, and change it into molecules. So we have to use liters and molecules. So I gotta get rid of liters, Cl2, and that's for 1 mole. And then change moles into molecules because they represent chlorine. Molecules represent chlorine. Okay, so 1, Avogadro's number of molecules, make sure your conversion factors are true, 22.4 liters. Okay, you do that answer and then we'll see what we get in class. Alright, so here's some tricky questions. How many atoms of hydrogen are in 13.7 grams of water? Okay, well here's water, H2O. So what represents water? A molecule. But what's part of that molecule? Hydrogen atoms. So this is actually 3 steps. 13.7 grams of H2O. The first step, we got to change grams into moles. But it's still water the whole time. Still water. Grams of what? Grams of water. And then moles of water can help us get to molecules, because that's what represents water, molecules. All right, but then for every 1 molecule of water, there's actually 2 hydrogen atoms. Okay, so that's our last step, but we're not using these conversion factors. We're using the fact that water has 2 H's. So 1 mole is 18.02. How do I get that? I go to the periodic table. And then 1 mole has Avogadro's number of molecules. And then 1 molecule has 2 atoms of hydrogen. So it's time for the calculators. 13.7 divided by 18.02 times 6.02, 10 to the 23rd times 2 gives us, that is a lot of hydrogen atoms, 9.15 times 10 to the 23rd hydrogen atoms. Okay. Let's save this one for class. Get ready. See if you can figure it out, and we'll do it in class. Ammonium nitride. You gotta be careful with that. Okay. Here's some simpler questions. This is moles already. 3.59 moles of what? Ammonia and H3. Oh, I should tell you that's what it is. What volume? Well, 1 mole of ammonia has 22.4 liters. And so this is only 1 step because you only have to use moles and liters. It's 1 step because both of those units are in that same conversion factor. 3.59 times 22.4, and you get 80.4 liters in H3. All right, we're saving this one for a class, and we're going to review. Moles are groups or particles or anything that has Avogadro's number, 6.02 times 10 to the 23rd. It represents, all right? Make sure you know what a formula unit, molecule, atom, what those are. Make sure if you want to do molar mass, you go to the periodic table, go through moles, and 1 is the number that goes with moles. All right, so I'm taking out with the mole song. So. Grown-ups, boys and girls, there wouldn't be a single soul down and out of luck, 'cause everybody in the